So let's talk about the sine law, specifically the missing angle case. So we'll go over a little bit of sine law in general, and then we'll talk a little bit more specifically about how to use it to find missing angles on a triangle. So sine law can be used on any triangle, given that you have the correct information from the triangle to use it. But as long as you have that information, it is true for every single triangle you could use. Okay, so when we're talking about a triangle in trigonometry, we tend to label it as such. We tend to label it, if we have the angles as capital letters, in this case I'll choose A, B, and C. They can be any capital letters, it doesn't really matter. They tend to be in sequence, A, B, C, X, Y, Z. That's just a convention. It's just something that we decided would make sense. So this is triangle ABC. And A, B, and C have paired sides. So if we look at the angle A and we go all the way across to its opposite side, that was going to be its pair, little a. Right? So big A is paired with little a. And we do the same thing for each and every other side. So big B goes to little b, big C goes to little c. Okay, it's important that this is always our first step in any trig problem, just because as soon as we start writing the formulas, we have to know what sides we're talking about. Okay, so sine law for missing angles looks like this. It is an equality of ratios such that the sine of big A over little a, so the sine of an angle over its side pair, equals the sine of B over little b, which equals the sine of C over little c. So what that really means is the ratio between the sine of an angle and its side pair is always going to be the same for any pair in the same triangle. So the ratio of these two, the ratio of these two, and the ratio of these two are all going to be the same. And because they have an equality there, we can use those values to solve for missing values. Which means as long as we have every other value in the equation, we can solve for an angle. Okay, so we're going to do this in a few steps. I'm going to go over the steps quickly here, and then we're going to do an example where we use those steps. Okay, so these steps might not make sense right away, but they're here for you to reference later on. Okay, the first step, like we just did, is going to be to label the triangle. Okay, it is important that we always do this, just so that we can go from whatever numbers we're given to whatever equation we're using. Okay, don't want to get stuck wondering, okay, which side was A again? It should be clearly labeled. Okay, the second is to find our two pairs. Okay, so find two pairs specifically, we're looking for a complete pair which means that you have both values. So if B was a complete pair, I would have the value for big B and little b, not just one or the other, but both, I'd have them. That's a complete pair. But there's also the incomplete pair. Okay, so this is the pair that has the thing that we're solving for. So for example, if we're solving for angle big A, then our incomplete pair would be, we have to have side A, and then that would be our incomplete pair. Okay, so then 3, we have plugged values into formula. I'll show you how to find that formula in just a moment. Let's plug values into formula. Okay, then number 4, we isolate the variable on the left. Again, I'll show you this one is much better to see than to just have it written out. This is just for your reference later. Then we solve the right hand. So we solve the right hand side. Use inverse sine, sine minus 1, to find the answer, or find your solution. And then number 6 is just an extra step just because we need something to round this to. I'm going to say for my purposes, I'm going to round to the nearest degree. Okay, so if a question says to round to a different place, round to that place. Ignore me. If it doesn't say anything, round to the nearest whole degree. Okay, so those are our steps. Let's take a look at how we actually use them. So let's say we're given a triangle like this one, with the measures as noted. We have a side length of 20, of 15, and of 110. I know that looks like a 90-degree angle. It's just how the program autocorrects it, but we'll assume it's larger for this case. With the instructions to find the measure of angle B. Okay, so the measure of angle B, we know that that's going to be this one right in there. Okay, so that is the one that we're solving for. Keep that in mind. But we're going to use our steps in order here. So let's take a look. We're going to first label our sides. So we've got big A over here. We look all the way across. That's little a. We got big B over here. We look all the way across. That's little b. And we got big C over here. We look all the way across. That's little c. Okay, so those are our sides. Okay, so now we can find our pairs. So first we need the incomplete pair, then the complete pair. So again, the incomplete pair is going to be the one that we're looking for. So we know we're looking for big B, and we know its pair is going to be little b, which means that the first part of our formula is going to be sine of big B over little b, the incomplete pair. Okay, then we do equals, and then on the other side of this, we're going to put the complete pair, rather. So if we look at our triangle here, A has no values, little a has no values, so that's not our complete pair. Big C has a value, little c has a value, which means that's a complete pair. So let's use that. So we got sine of big C over little c. There we go. So now we've got a formula. We just have to stick some values in it to solve it. So let's rewrite it with all the values in it. So sine of, we don't know what big B is, so we'll keep it as big B. But little b, we know is 15. And that equals the sine of C, which is 110, over little c, which we know is 20. Okay, now we isolate the variable on the side. So in this case, that's the sine of b. So to isolate it, we have to get it on its own. We have to get rid of this divided by 15. Now in math, when we want to get rid of something that is dividing, we have to do its opposite, which is multiplication. So we do times, and then whatever we're trying to get rid of. So times 15, right? Because those will cancel. But it's math, it's fair, so whatever we do to one side, we have to do to the other side, times 15 on this side too. So if I were to rewrite this just to make it look all nice, sine of big B equals the sine of 110 times 15 divided by 20. Okay, so now sine of B, it's on its own, so we can just start solving this side here. So if we, first we'll find the sine of 110. Okay, so that's just in your calculator. Enter the angle, press sine, or the reverse depending on your calculator. But what you should end up with is sine of B equals the sine of 110, which is 0.9397. I like to keep it to 4 decimal places here. Okay, and then we do times 15 over 20. And remember, when I have brackets like this, it means times. It's the same thing. I could write times in there, but it would be the same thing. Okay, so we multiply the top together and then divide by the bottom. So doing that in a calculator will give us 0.7048. Now that's not an angle, that's way too small. But we're not at angle yet. We've got an angle there, but we've got a sine here. It's the sine of the angle. So we have to undo that sine. So just like the step tells us to do, we're going to use the inverse sign just to undo the sine. And we do that on both sides. So sine cancels over here. We take the inverse sign on the right-hand side, and again, that is on your calculator, usually under shift sign. is how you would get to it. Okay, but doing that on your calculator should give you b on the side equals 45 degrees. And again, I'm rounding to the nearest decimal here. Okay, so that's going from a triangle using the incomplete and complete pairs, isolating the variable, calculating the right-hand side, and then using the inverse sign to find our final answer. Okay, so that is sine law in missing angles. Missing sides is very similar, but I'll cover that in another video.